So today's point is bridge rectifier. Here bridge rectifier is one type of full wave rectifier which converts AC signal into DC. To construct this bridge rectifier, 4 PN junction diodes are required. First of all, we will see the circuit diagram of this bridge rectifier. Here in this circuit, 4 diodes, diode D1, D2, D3 and D4. These are connected to form a bridge. Then here single phase 230 volt AC signal is taken as input, and that AC signal is connected to primary winding of the step down transformer. Then one diagonal of this bridge is connected to secondary winding of this step down transformer, and through second diagonal the output DC voltage is taken. Then here one load resistance is considered. Through that load resistance RL, load current flows, that is IL. Then across this load resistance output DC voltage is available, that is load voltage EL. So in this way, this is the circuit of this bridge rectifier. Next we will see the operation of this bridge rectifier. To explain operation of this bridge rectifier, first consider positive half cycle of the input. This first operation in positive half cycle of input. So consider positive half cycle of the input. So in positive half cycle, voltage induced in secondary such that this point A is positive and point B is negative. Assume that the voltage across secondary winding is ES. When input is positive half cycle, then positive half cycle is induced in the secondary winding. So this point A is positive and point B is negative. So upper point of this bridge is positive and this lower point is negative. So because of these polarities, anode of diode D1 is positive, therefore diode D1 is forward biased. Similarly, cathode of diode D2 is negative, therefore D2 is also forward biased. Then cathode terminal of this diode D4 is positive, therefore this D4 is reverse biased. Similarly, anode terminal of this diode D3 is negative, therefore D3 is also reverse biased. So in positive half cycle of input, diode D1 and D2 are forward biased and D3 and D4 are reverse biased. So current flows through D1 and D2, and these two diodes D3 and D4 can be replaced by open switch, Here replace these two diodes by open switch, because no current flows through the D3 and D4. So here current starts from this positive point A, then that current flows through diode D1. After that, current flows through the load resistance, that is IL. Then that current flows through diode D2 and finally through the winding. So current completes the loop and through this load resistance current flows called load current, that is IL. So when load current flows, then load voltage is available, means this output voltage EL is taken across this load resistance, and this EL means output voltage depends on the current and the value of the load resistance. So this output voltage depends on the current and this load current depends on secondary voltage. So if we consider the waveforms of this bridge rectifier, then first consider the secondary voltage as an input. So here ES is the secondary signal, that is input. Then second waveform is of load current and third waveform is of load voltage. So in positive half cycle of the input, so if we consider this positive half cycle, then diode D1 and D2 are on. So current flows through diode D1, D2, then through the load resistance and finally through the winding. So this current, load current depends on the this secondary voltage. So when secondary voltage increases, load current increases. When secondary voltage decreases, load current decreases. So output current flows, means load current flows, which is positive during positive half cycle of the input. So when this load current flows, then load voltage is available and that voltage depends on the current. So when load current increases, that load voltage increases. When load current decreases, load voltage decreases. So in positive half cycle of input, at output positive half cycle is produced. So this is operation during positive half cycle of the input. Then after completion of positive half cycle, negative half cycle starts, means operation during negative half cycle of the input. So consider negative half cycle of the input, therefore negative cycle induced in the secondary. So because of this, polarities of point A and B are reversed. So point A now negative and point B is now positive. Then here upper point of this bridge is negative and this point is positive. So consider all diodes first. So if we consider all 4 diodes, here diode D3, so in negative half cycle, here the upper point of this bridge is negative, therefore cathode terminal of diode D4 is negative, therefore D4 is forward biased. Similarly, anode terminal of D3 is positive, therefore D3 is also forward biased. But here anode of diode D1 is negative, therefore this D1 is reverse biased. Similarly, cathode terminal of D2 is positive, therefore D2 is also reverse biased. So in negative half cycle, diode D3 and D4 are forward biased and D1 and D2 are reverse biased. So current flows through D3 and D4. and we can replace diode D1 and D2 by open switch. So here consider the open switch for two diodes D1 and D2, means no current flows through D1 and D2. So in negative half cycle, current starts from this positive point, then that current flows through this diode D3, then current flows through the load resistance. After that, current flows through this diode D4, and finally current flows through the secondary winding. So in negative half cycle, current flows through the load resistance and load voltage is available. Here direction of this load current is same as direction of current in positive half cycle, means in positive half cycle the direction of current, and in negative half cycle direction of current is same. Therefore even if input is negative, the load current is positive, means here when input, negative input increases, load current increases. When negative input decreases, load current decreases, means the current flows because of the diode D3 and D4, and that current is positive because direction is same, current direction is same. So when current flows, then load voltage is available. So when load current increases, load voltage increases. When load current decreases, load voltage decreases. So in this way, in positive half cycle, load voltage is available, which is positive. In a negative half cycle of the input, load voltage is again positive. Since polarity of this output, here EL is the output signal, polarity is constant, means here positive half cycles are produced, continuous positive half cycles are produced at the output. Therefore input AC signal is converted into DC by this bridge rectifier. So in positive half cycle, diode D1 and D2 are on, therefore output is positive, and in negative half cycle, diode D3 and D4 are on, therefore output is positive. Then after completion of this one complete cycle, again positive half cycle start, again diode D1 and D2 are on and load current flows, therefore load voltage is available. So we get continuous positive half cycles at the output. So this type of output is called pulsating DC signal. So this pulsating DC is then converted into pure DC signal by using filter and the regulator circuit. So this is the operation of this bridge rectifier. Here the advantages of this bridge rectifier are, the first advantage is no need of center tap transformer. Here the center tap transformer is not necessary. Second advantage is the efficiency is high, means here maximum efficiency of this bridge rectifier is 81.2%. Third advantage is the ripple factor is low, means here ripple factor is 0.482, which is low. Then fourth advantage is peak inverse voltage is also low. Here PIV is only VM. So because of these advantages, this bridge rectifier is preferred in DC power supplies, means in regulated DC power supplies, to convert AC signal into DC. Then this bridge rectifier has few disadvantages. That one disadvantage is need of 4 diodes, means 4 diodes are required. Therefore the circuit is somewhat complex. Then second disadvantage of this bridge rectifier is the voltage drop is more. Here voltage drop across two diodes is equal to 1.4 volt, because here in each half cycle two diodes are on, therefore there is a voltage drop across one diode. Voltage drop is 0.7 volt, and if two diodes are on at a time, then 0.7 volt plus 0.7 is total 1.4 volt voltage drop. So because of this voltage drop there is a loss of power. So as compared to the disadvantages, advantages are more. Therefore this bridge rectifier is preferred in DC power supplies. So this is all about this bridge rectifier.